Hello. Hello, am I audible?
भाई अभी कैमरा बंद है क्या? भाई कैमरा हाँ एक बार टेस्ट कर लो.
Hello, am I audible?
130. Welcome, sir. Good afternoon.
Good afternoon. Am I audible to you?
Yes, sir.
Fine.
At 2 o'clock, we will start the session, sir.
Yes, yes. Okay, okay. Fine.
Thank you, sir.
Yes, sir. Online जरा किस तरह फोन करा
Sir,
Yeah, hello.
sir, I think you received the evaluation sheet by mail.
Yes, yes, I will give.
Sir, please fill that one, and after the evaluation, please send through mail, sir.
Okay, okay, no problem.
Okay, sir. Thank you. Mr. Tanu Patel. Mr. Tanu Patel, am I audible?
Yes, sir, audible.
Please confirm your paper ID.
Sir, my paper ID is 191.
Sir, Mr. Ankit Pal,
Yes, sir.
please confirm your paper ID.
Yeah, sure.
Sir,
Yes.
actually we are waiting for internal chair session. We will wait for a couple of minutes, sir.
Okay. By the time I just meet my video.
Yes, sir, I will inform you, sir. Aman,
Good afternoon, sir.
good afternoon. Please confirm your paper ID.
Paper ID is 7.
Paper ID is 7. Aman.
Yes, sir.
Okay, thank you. Mr. Aniket Pal.
Sir, paper ID is 7, sir. 7. We are
7?
together. Yeah.
Aniket's paper ID is 7.
7, yes, sir.
Mr. Aman, your paper ID?
So we are together.
Okay, आपका okay. Aniket. Okay, thank you. Mr. Sachin, please confirm your paper ID.
Sir, 130, sir.
Thank you. Dr. Patil, sir,
Yes, I like.
shall we start, sir?
Yeah. Okay.
Okay, sir, thank you. Well, since everyone is here, we should get started. Good afternoon, everyone. On behalf of IEEE, Naya Raipur, I, Raju Gupta, research scholar, would like to welcome you all to the second session, Distributed Computing System track in second version of IEEE International Conference on Blockchain and Distributed System Security, ICBDS 2023, organized by IEEE Naya Raipur. I will be handling this session, which will run from 2 o'clock to 3:45 p.m. There will be 5 paper presentations and each will have 15 minutes for paper presentation, followed including 5 minutes for question and answer session. Before going to start with the presentations, let me welcome session chairs with a brief bio. I welcome our external session chair, Dr. G. A. Patil, with brief bio. Dr. G. A. Patil is highly respected educator, researcher, and administrator with a distinguished career in the field of computer science and engineering. With a wealth of experience spanning over 3 decades in academia and a remarkable track record in research, Dr. Patil is a notable figure in the academic community. Dr. Patil's educational journey is marked by his relentless pursuit of knowledge. He holds a PhD in computer science and engineering. In the academic realm, Dr. Patil has devoted 31 years to undergraduate education and 17 years to postgraduate education. He currently serves as a professor in the Department of Computer Science and Engineering at D.Y. Patil College of Engineering and Technology, Kasba Bawada, Kolhapur. His profound impact on the education and development of countless students is a testament to his dedication as an educator. Dr. Patil's administrative acumen is equally noteworthy, with 14 years of experience as the head of department and dean academics. His leadership in these roles has played a pivotal role in shaping the direction and standards of his institute. Dr. Patil has authored 42 research papers in esteemed journals and presented 35 papers at prestigious conferences. Additionally, he holds an innovation patent and 2 copyrights, highlighting his innovative thinking and contributions to the intellectual property. Dr. Patil is an active member of the professional bodies such as IEEE Computer Society and CSI. His areas of research interest includes distributed systems, cloud computing, information security, cyber security, network management, and theory of computation. His contributions in these domains have garnered recognition and respect from academic and research communities. Dr. Patil's achievements are not limited to his academic and research pursuits. He has received numerous awards and applauds, including a certificate of excellence for his contributions as the Akash project coordinator under the National Mission of Education through ICT led by IIT Bombay. He has also been honored as the best mentor for TGMC program by IBM Bangalore. Additionally, his dedication to his education has been acknowledged with certificates of recognition for his contributions as a member of the Academic Council, which had a significant impact on the development of Shivaji University and higher education in general. Dr. Patil's influence extends beyond his immediate academic sphere. He has presented Shivaji University on the board of governors of several engineering colleges, further contributing to the development of the technical education in the region. His dedication to education is innovative research and
Audio system on the
extensive contributions to the academic community
on the MRC.
continue to inspire and shape the future of technology and engineering education. Welcome you, sir. Now, I welcome our internal session chair, Dr. Anurag Singh. Dr. Anurag Singh is an assistant professor in the electronics and communication engineering discipline, IIIT Nairapur, and brings a wealth of expertise to the academic community. He has held faculty positions at esteemed institutions such as NIT Jaipur and Thapar University, Patiala, Punjab, prior to joining IIIT Nairapur. Dr. Singh earned his PhD in biomedical signal processing from the prestigious Indian Institute of Technology, Guwahati, and holds an MTech degree from the Indian Institute of Information Technology and Design and Manufacturing, Jabalpur. His academic journey is marked by numerous achievements, including his participation in the Indo-Japan Student Exchange Program, Genesis 2011. He has been recognized with an international travel grant, young scientist from Department of Science and Technology, Government of India. Dr. Singh is also a sought-after speaker and has been invited to share his expertise at various national level workshops. Dr. Singh's research interests lie in the field of biomedical signal and image processing, with a focus on wireless body area networks, BPAN, enabled remote healthcare applications using psychological signals like ECG and EEG. He is also involved in brain-computer interface-based applications, multi-rate signal processing, compressed sensing, space representation, and related areas. His contributions to academia extend to serving as a peer reviewer for numerous reputed international journals and conferences. Additionally, he is an active member of IEEE, Signal Processing Society, and Engineering in Medical and Biology Society. Welcome you, sir. Now, we will start first paper presentation with paper ID number 7 by Aman and Aniket.
Mic on.
Aman and Aniket, please confirm who is the host for this presentation first. Aman or Aniket?
Hello.
Yes, sir.
Please confirm whose name need to share as host.
Aman, will you share the screen?
Okay, Aman.
Yeah, I'll share the screen.
Yeah, just a moment. I'm making you as the host. Yeah, now you can share your screen.
Okay, sir.
Okay, it is visible. You can start now.
Is it visible, sir?
Yeah, it is visible.
Yes, sir.
To all the chairperson and professors from IEEE, and today we are going to present a paper that we have prepared, that is implementing secure key management and distribution in cloud environment. And the authors are me, myself, my friend Aniket, and Dr. Amar Buchresha, Dr. Jagannath Nalwade, and Ranjit Bedvesha. So the abstract will be explained by Aniket. Can you explain that?
Yeah, hello. Good afternoon, everyone. As we can see that our organizations increasingly move operations to the cloud, the demand for secure key management solutions has never been more critical. So cloud service providers offer key management services, but challenges persist in key storage, access control, and rotation. So our research aims to address these challenges by developing a secure and efficient key management solution for cloud-based systems. So we propose a system that combines various cloud services and encryption algorithms to generate, store, and manage cryptographic keys securely. Also, our system ensures granular access controls and strong encryption, safeguarding the confidentiality and integrity of keys. We believe this solution will help organizations manage cryptographic keys more efficiently and securely, which reduce the risk of unauthorized access and data breaches. Aman, next slide, please. So, moving on to threshold cryptography, a crucial aspect of our research, which is currently one widely used scheme, is Shamir secret sharing, but it has computational limitations, especially with a large number of parties or a high threshold value. So, to overcome these limitations, our research combines the Shamir scheme with Newton's divided difference interpolation. So, this innovative approach reduces the computational complexity, resulting in faster reconstruction times and improved efficiency. Looking ahead, Aman, will you explain the next slides?
The introduction. So in the traditional key management system, there used to be a single key that is used to encrypt and decrypt the data. So this key needs to be stored securely and managed in order to prevent the unauthorized access or data loss. So there used to be a single key that is used to encrypt and decrypt the data. It is very difficult for managing the key, and when the key is compromised, then the data encrypted with the key is also compromised. So in the cloud computing, a efficient key management is very necessary, and in order to protect sensitive data from unauthorized access and modification and theft. So considering all these reasons, we have proposed an efficient cloud-based application for key management using the threshold cryptography. So the concepts and method that we are going to use for this project is like we are going to use a threshold secret sharing scheme. So in threshold secret sharing scheme, it is a scheme that is used to create a secret key and divide that secret key into many other shares and distribute each of the shares to the communicating parties within the organization. So a particular threshold number of key is required to generate the original key. So the threshold number of shares will get combined in order to generate a secret key. So polynomial interpolation, it is a technique that is used to generate the secret key passing through a given set of points. And for this today, we are going to, in this project, we are going to use the Newton's divided interpolation polynomial. And generating the key, the code uses the data from the user and the key, and it applies the key derivation function using password based method and for net symmetric encryption in order to generate the key and encrypt the data. So generating the shares, we're going to use the sum is secret in order to generate the multiple share that passes through a given set of points. And computing divided difference, it is the method that uses the shares in order to define its y values that passes through the given set of points using that algorithm that I have described earlier, that is the Newton's interpolation polynomial. And for the regeneration of the secret, the traditional method was used with Shamir along with Lagrange's interpolation polynomial. And for our project, we're gonna improvise that on using Newton's divided differential algorithm. So the methodology that we are going to use is that the data that is going to be stored is encrypted using AES first in CVC mode and 4-net symmetric encryption, that is along with KDF, that is password based key derivation function, which takes password and salt value from the user, and it applies the pseudo random function hmark again and again to in order to derive the key. So first, a user is required to enter a data that needs to be stored in the cloud, and the user have to apply the give the password and salt value, and the encryption algorithm stores that encrypted file and the key in the cloud storage service, that is S3. So the S3 management console is used to store the keys generated and the encrypted file. So the derived key is then split into n number of shares, which can be stored at different places or distributed to different users. So for this context, we have implemented that in cloud. So we have created various 5 to 6 instances, and we have divided this secret shares and distributed among individually to each one of the instances. So finally, when the users want to decrypt the data, then he will require the minimum number of shares, that is t out of n shares. So that when the t is less than n, then it is only able to recover the original secret, and then they can use to recreate the original secret using an algorithm called the Newton's divided differential interpolating polynomial, which allows us to reconstruct any polynomial of degree t minus 1 from t point on this curve. So it is all the mathematical terms that I have used here. As a result, the system is even better secured because an attacker who has t minus 1 shares or more will not be able to decrypt the data. So like if there are a 5 number of shares that is distributed among each one of the parties, so the threshold number required in order to decrypt the share is 3. Then if one party loses its share, then it can use the remaining other 4 in order to retrieve the original secret. So it is safer in sense that a legitimate user will still be able to decode the data even if he loses n minus t shares by regenerating the original secret with the remaining k shares. In this way, we can boost the security of the data that is being used with the large number of smaller shares comparison to traditional KMS. So the result and discussion, this is the setup that I have created earlier, and sorry, I can't create today. Like I don't have any in this cloud, I don't longer have this cloud. So this is the screenshot that I've taken during the college presentation. So at that time, we have,
Slides are not visible. Hold on,
sorry, sir.
your slides are not visible. Only the first slide is. So,
This is visible. This result and the discussion is visible, sir.
Aman, zoom it, zoom it.
Okay, so how do I zoom this, sir? Just find it. So these are the instances that I've created. This is the 6 pieces that I've set up in AWS Cloud, and these are the buckets. And this share generated bucket is used to save the share generated, and key management bucket is used to store the generated secret key and the encrypted data. This is the management. This is the IAM management console that is used to control the identity and access management. Next slide. This is key splitting. So here we are. So the user is required to enter the data that needs to be encrypted. So here he types, "Hi everyone, welcome to my project scheme," and he is required to enter a
Mr.
secret
Raman?
password. Yes, sir.
Please speak somewhat louder.
Okay, sir. So in this key generation, the user is required to encrypt the enter the data that needs to be encrypted, and here he inserts like, "Hi everyone, welcome to my project scheme." So he's also required to enter the secret password, and here he enters welcome and salt value, that is all. And this combinedly creates a encrypted key and encrypted data in the S3 bucket that I've shown earlier in this key management project. Okay, so in the second step, we are going to distribute and make the shares. So here the user enters like enter total number of share, and if he enters 5 and the required threshold 3. Okay, so there are five shares created, and it is all stored in this shares generated bucket in the cloud. So in the next slide, like there is this automated distribution in the instances that I've created using SSH, that is secure file sharing protocol, and I have distributed evenly to all of the instances. These are all the instances that I've created and distribute the shares. So in the first PC gets the share 1, and the second PC gets share 2, third PC gets share 3. Likewise, I've distributed evenly to all of the instances in the cloud. And the last step that is used is like key regeneration. Now we have generated the key, we have distributed all the shares. Now it's the time to generate the original secret. So the user enters how many number of shares do you have, and he says like, we have 5 shares and the threshold value is 3. Like only we have 3 number of communicating parties, and the code asks the user like, "Do you know your password?" and he enters welcome and all, and like the original secret is and the original secret is decrypted. Like, "This is the hi everyone, welcome to my project. This is the original data that we have used to encrypt it." So the so So this is the key regeneration time between the summary secret and
Mr.
proposed
Raman?
scheme. Yes, sir.
Please conclude in 2 minutes.
Okay, sir. So this is the regeneration time that we have uh, that are between the summary secret and our proposed scheme, and our proposed scheme performs better in both the key sizes, that is 128-bit and 256-bit. This is our yellow line is our proposed scheme, and the blue one is the traditional KMS, and the threshold scheme that is used. And for the 10 number of shares, we have 5 thresholds, and summary secrets here in scheme took 0.1 and we have 0.10. So even there is slight number of percentage difference between these two scheme. Our scheme performs better in terms of key regeneration, key splitting, and the various number of key sizes. So I believe that even there is slight difference of 2 to 3% in the key and regeneration and generation time. I think it is an acceptable trade-off. So the conclusion will be explained by Aniket. Thank you. Aniket, can you?
Yeah, so our proposed scheme, so let me first go through the future work and then I'll conclude. So we intend to conduct a comprehensive security analysis, evaluating its resilience against a variety of attacks. This includes scenarios like node compromise, reply attacks, and man-in-the-middle attacks. Another future aspect is like to truly cause its capabilities. We plan to test the system in a large-scale environment, cloud environment. So this exploration will focus on measuring critical aspects such as key distribution time, communication overhead, and scalability. So, concluding the presentation, our proposed scheme can provide a secure way of managing keys in cloud computing environments, and the polynomial can help to distribute keys among different instances in the cloud environment, making it difficult for an attacker, obviously, to access all the keys at once. And the use of this polynomial can also help to reduce the communication overhead in key management by reducing the number of messages exchanged between instances. Thank you.
Thank you, sir.
Yeah, okay, the presentation was okay. You know on what cloud platform do you experiment with?
Sorry, sir. I can't hear you.
Yeah, on which cloud platform you have experimented with?
Sir, AWS.
On AWS.
AWS platform, yes.
What are the limitations that you came across?
Sorry, sir.
What are the limitations that you have identified?
Sir, in traditional KMS, like when there is used to be like big number of key sizes, then the time taken by the like the traditional KMS used to be like higher, using that more, taking the more resources from the cloud, and taking the more time to regenerate and store the keys. And our scheme provides the minimal, takes the minimal number of resources and the time in order to generate the secret key and share.
No, what is the size of key that you generate?
Sorry, sir.
What is the size of the key that you have generated?
So we have a test with both 128-bit and 256-bit key sizes.
And after generating that size, you are dividing it into chunks, fine?
Yes, sir.
So what is that dividing factor?
Sorry, sir. Dividing factor.
Yeah.
So we have used the summary secret in order to generate the keys and newtons in order to distribute it to the other instances.
Okay, fine.
Yes, sir. Thank you, sir.
Sir, any questions?
Mr. Amar, can you hear me?
Yes, sir.
So, briefly tell me, what is your contribution in this?
I can't hear you properly.
What is the novel thing you contributed in this block?
What is the
I can't
novelty
hear
from
you.
your presentation? What is the novelty from your work?
Like the new from this project.
Yeah, from your work.
Okay, so in the traditional KMS, there used to be like Lagrange's interpolation polynomial that is used in order with a summary secret, and we have proposed a scheme. It is with the summary only, but it uses the Newton's polynomial that passes with the polynomial parallelly in for the faster retrieval and the key regeneration. So we have proposed a new algorithm only. We have used a new polynomial, mathematical polynomial, in order to generate and distribute the shares. So can you repeat the question?
Aman, we have done the comparisons, right?
Yes, sir.
Can you please show that
Comparisons.
comparisons of various threshold cryptography algorithms? Hello, Aman.
Yes, sir.
This is done by you or others?
Sir, I've done it myself only.
This is done by us, sir. This is done by us.
Yes, sir. This is done by us.
The readings are taken by us. Yeah.
It is not easy to get actually what you want to convey. So you must work on your presentation first. And since fonts are getting so small that even very close, I can't see anything. So that's why I need to ask. Is it I'm asking that whether the existing ones you're comparing? It seems not, I think the younger can see one.
But analysis is done.
We go to this one.
Okay, thank you for your presentation.
Thank you,
Next,
sir.
we will move for the next presentation by Tanu Patel.
Thank you, sir.
Yeah, we work it.
Mr. Anma, Ms. Tanu Patel, you can present now.
Okay, sir.
So can we leave the meeting?
Yeah, you can.
Okay, sir.
So, may I know the paper ID?
So paper ID 191.
Sir, may I start?
Yeah, you can start now.
Good afternoon, sir. I am one of the co-author of the paper titled Comparative Analysis of Regression Techniques for Accurate House Price Prediction Using Machine Learning, a Statistical Analysis Method. The corresponding author is Honorable Dr. Malika Arjun Rao K, and me and my friends are the co-author. So, accurate house price prediction, it plays a crucial role in the real estate. So the research aims to build a model for house price predictions that can predict the price of the house accurately using the regression techniques. We have evaluated the models using R2 score and through k-fold cross validations. And the top performing models, it undergoes hyperparameter tuning. So overall, we have shed lights on the effectiveness of regression techniques for predicting the house price. Accurate, as already mentioned, accurate house price prediction, it plays vital role in dynamic real estate, impacting the house owners and sellers and the buyers. So our aim is to build a model that is capable of comprehending the complex features, interactions, and generalizing effectively. By saying this, we mean that the model must be able to understand the intricate relationship between various features, and it must generalize well on unseen data. The foundation of our study is the Ames housing dataset, and this research thus aims to find the most effective regression techniques by comparing various regression techniques for house price predictions, emphasizing the importance of model selections and hyperparameter tuning. So this is the methodology which we have followed. First, we have done data collection, that is the data set we have, and then we did data visualization. After that, we have done data pre-processing. And data pre-processing, we have it's a three-step process, we can say. Here we have first imputed the missing values, and then we have encoded the data. The label encoding and the one-hot encoding we have followed, and then we did the feature scaling to bring the values in a fixed range. After the data pre-processing, we have gone for model selection. We have followed this suite of regression techniques: linear regression, support vector regressor, random forest regressor, decision tree regressor, gradient boosting regressor, and XGBoost regressor. And then among this, when we followed the best models, best performing models, we have tuned the parameters of that model. And after that, on the tuned parameters, we again trained the best performing models, and we have evaluated the models using cross validation and R2 score. So this completes the methodology which we have followed. So the data pre-processing, here we can see that in data pre-processing we have used mean imputations, mode imputations, and median. So I would like to throw some lights on this. For the data which were normally distributed, that is the data which follow bell-shaped curve, means the features whose distribution follow bell-shaped curve. For that feature, we have used mean as the imputation. For the right skewed or the left skewed data, we have used median imputations, and for categorical data, we have used constant as well as mode for imputation, means either constant or mode for imputations. We have used constant for those data where NA was also a category, means it was not a missing value, it was a category when that particular feature was not available. So for that we have used constant, and either else we have used mode imputations. After imputing the value, we have done categorical to numerical, means we have converted the categorical variables to numerical. And for this, there were categorical variables which were in order, those we call as ordinal variables, and for them we have used label encoding to give higher weightage to the one which is more preferred, which has carries higher value, like excellent, good, better. So for so in this, excellent is means more it carries more value than better. So likewise this. And nominal variables, for the categorical variables which does not follow any orders, we have used nominal variables. Sorry, those are nominal variables, and for them we have used one hot encoding. So there were also categorical variables which were, means whose values were in number, even though there was not any order for them. So for them we have first for those we have first converted them to categorical, and then we have done one hot encoding for those. So model performances and the scores. So the series of regression techniques which we have used are linear regression, support vector regression, decision tree regressor, gradient boosting regressor, random forest regressor, and XGB regressor. The primary evaluation metrics which we have used are R2 score, and to ensure the robustness and mitigate the overfitting problem, we have used cross validations. What happens in cross validation is the whole data set is divided into K folds, means K parts we can say. The model will be trained for one part of one of the kth part, and it will be tested on remaining part. Likewise, it will be trained for kth time, and we will get R2 score for each kth time. And so in order to get the overall R2 score, we take average of this R2 scores. So after performing this regression techniques, we have got the best performing models. So we have done parameter tuning for that models. In our case, gradient boosting regressor, it performed best, so we have done hyperparameter tuning for this. Now there are various methods for hyperparameter tuning, like grid search, random search, and Bayesian optimizers, and many more. So what happens is in grid search, it exhaustively goes for each and every possible combination, so it's very exhaustive methods. And in Bayesian optimizers, it is computationally expensive, so we have gone for random search, which is a simple and straight method to optimize the parameters. The optimized parameters are here shown for the gradient boosting algorithm. Sorry, gradient boosting regressor. The learning rate, it was earlier this and this. The learning rate, it is the step size at which the predicted values are getting updated, and maximum depth. What happens in a gradient boosting regressor is it takes the predictions of the multiple decision trees and combines those results and gives the final output. Since decision trees are being involved here, so the maximum depth here earlier was 3, and means so we have maximum depth here. The maximum depth earlier was this, and the best value was this. Likewise, we have maximum features, means the maximum number of features to be considered while splitting nodes in the decision tree. This is the maximum feature, and earlier it was none. None means all the features were getting considered for splitting a particular node. So instead of none, it was scaled down to square root, means under root of total number of features that will be considered, means this much amount of features, this much amount of features will be maximum features to be considered while splitting a particular node. mean sample leaves means the minimum number of minimum number of samples to be at the leaf node, if any was there. We were checking, so it was earlier one, and later on also it was one, meaning that it was not, means there was not any specific minimum sample leaf nodes to there. Minimum sample splits means at each internal node minimum samples that can be splitted. It is the number of that. So earlier it was this, and later on after tuning we have got this. N estimators, it refers to the number of decision trees that we are going to use for predicting. As I already mentioned that gradient boosting regressor, it combines the results of multiple decision trees. So the number of N estimators, it refers to the number of decision trees to be used for predicting the value. It was earlier this, and then after tuning we have got this. This way we have systematically addressed the problem leveraging the machine learning techniques, and we have demonstrated the potential of gradient boosting regressor with accuracy of 86.7% after hyperparameter tuning. These are the performances of the various models. We can see linear regression, SVR, and then decision tree, random forest, and here we can see that gradient boosting regressor, it has performed best among all this. So after tuning the parameters of the gradient boosting regressor, we can see that the R2 score has increased. It has means it is better than earlier. This way we have developed the highly accurate price prediction models with an accuracy of 86.7%, and demonstrated its practicability in the real estate for informed decision making. The benefits to this is it empowers stakeholders for precise property evaluations, and it can be easily deployed in the real estate sectors. And the methodology which we have, a methodology, that is techniques and the technology and the knowledge which we have gained throughout, it can be used for further data driven projects. And the limitation includes the data availability. And model interpretability challenges, means how model reaches to its predictions, means it's not explained totally. So the future enhancements, it includes enhancing feature engineering to capture the nuanced property attributes, so that means with more feature engineering, more features could be included and the model performance could be improved. We can develop the methods for model interpretability, and we can also incorporate economic and market dynamics data, that is the data, the external factors which to influence the prices of the house. And another thing we can do is geographical regions, means for different geographical regions we can specify, means we can specifically build the models. And thus research marks significant progress in the real estate forecasting, offering practical insights and room for further exploration. Thank you. So these are my references, and thank you. This is it.
Good. Hello.
Sir?
Yeah. What are the features that you considered while analyzing?
So
while doing this analysis part?
So please, can you wait?
Am I audible?
Sir, wait. Sorry for the inconvenience. Hello.
Hello.
Yes, sir.
Am I audible now?
Yes, sir.
Yeah. Which features did you consider while this prediction, house price prediction?
While
predicting the house prices.
Hello.
Hello. Am I audible now?
Sir, but not clearly. I'm sorry.
In which geographical region you completed your work? You have done this work?
So geography.
Hello, am I audible?
Yes, sir, you are audible, sir.
Yeah. I would like to know in which geographical region the work is done and what are the features considered while predicting.
So features considered for what?
For your entire work, house spice.
For your entire work, you say.
Yeah.
Okay, so the features we have considered, it includes the various property related features like the square means the area of the house, the how whether the house is connected to any means how much portion of the street is connected to your house, and like the house is having garage or not, if it is having garage, in which year that was built, and in which year your house was built. Like this type of features we have considered, sir.
Fine. Then when you compare all these techniques, regression techniques, and finally you hyperchange the parameters.
Okay.
So while hypertuning, what are the parameters that you considered?
So the parameters that I have tuned, you are asking.
Yes.
So this is I have shown. So these are the parameters which we have tuned for gradient boosting regressor.
What are you? Can you just say because it's not visible on the screen for me?
So not visible.
Yeah.
Not visible.
You can read it, no problem.
Okay, sir. The parameters we have used is one is the learning rate, which is the step size of means updating the predicted values. Learning rate. So it was earlier 0.1, and the best value was which we have obtained is 0.032. And another thing we have tuned is maximum depth. Since gradient boosting regressor, it involves decision trees, so maximum depth is what we have tuned. Earlier maximum depth was 3 and the best value is 5. The maximum features means the maximum number of features to be considered while splitting a particular while splitting at particular node. Earlier it was none, meaning all the features were being considered at every node. So we have scaled down to this under root of square root of number of features. So this is the maximum features, and another is the minimum sample sleeve, means the minimum samples of the minimum samples required to be at the leaf node. Earlier it was 1, and after tuning also it is 1, indicating that there is no specific minimum samples of the leaf. Minimum sample split means the minimum number of splits that we can do at inside that we can do at the internal node. Earlier it was 2, and after tuning it is 6. And n estimator is the another parameter which we have tuned. An estimator is the number of the decision trees. Since gradient boosting, it combines the results of multiple decision trees. So earlier it was 100 decision trees, and after tuning it is 615 decision trees.
So out of these
So this
techniques,
is-
which technique you feel is better for prediction?
Sir,
Out of these techniques, which technique you feel better?
which technique should be better?
Yeah.
So we have used random search, means because grid search, means it follows a very exhaustive strategy, and means it checks for each and every combinations of parameters, and this computation
Okay. What you use?
So she's. Sir, any questions?
Yes, sir.
So, regression models we have used, couple of regression models will be trials for environment negative.
Sorry, sir, the question is not audible properly.
I'm saying there are models which we have used, regression models. Then couple of regression models were giving R score value negative. What does that mean?
Sorry, sir. Sir, not audible, not clear.
In that values, so few values are negative,
Okay, okay.
R square. So why that values are negative?
So because it happens that the values were negative in linear regression and SVR, right? So in linear regression, what happens? It assumes a linear relationship between the different features, it means dependent and different features. So means it is not that there is a linear relation between the features. It is because of the assumption of the linear regression, it does not fit properly, and it gave the negative result. And same goes with the SVR, because it also tries to fit the data around a hyperplane. So there also it happened.
And your values, I guess the maximum was 87%. Don't you think it is less to say it's a very accurate model?
Sir, your voice is not very clear. I'm sorry.
So actually, you given that accuracy as a maximum 87%.
Yes.
So that is somewhat low now
Oh,
compared
yes,
to
sir.
other rocks.
What would be the reason? Then you are
Yes.
getting at very good model, but still it seems less.
So that. So I'm sorry, I didn't hear. I am unable to hear your voice. I heard what Goodla sir said. So
What is the reason why your model is giving only 87% compared to other good models?
So the reason maybe the data pre-processing steps we have followed means we can go for more refinement and optimization of the process we have followed for increasing the accuracy.
Okay, Shamil, thank you. Thank you for presentation.
Thank you, sir.
वो mic अपन वहाँ use sir इस mic में use
Uh, Please confirm, others, who is presenting paper ID 94?
Hello.
Hello.
Hello. My voice is audible, sir.
Yes, Mr. Sahuji.
Okay.
You are presenting paper ID 94?
Yes, sir. My paper ID is 94, sir.
Okay.
Okay.
Uh,
So can we start? Can I start now, sir?
Yes, yes, yeah. Just
Shall I? Okay.
I am making you as yes.
Okay. Okay, sir.
You can share your screen.
Okay, sir. Okay. My screen is visible, sir.
Yeah, it is visible.
Good afternoon to everybody, respected dignitaries of this conference. I, Premanand Sahu, and my co-authors are Srikant Kumar Mahapatra, Kamakhya Narayan Singh, Prakash Kumar Sadangi, and Joy Srimanti are going to present the top title, that is a multi-step ahead predictive analysis of crude oil. The first part is our abstract, where the population is increasing in a rapid manner and the number of vehicles are increasing in the same ratio. Crude oils are very useful towards the energy needs in the industries. As a result, a day will come when we face the issue of filling the vehicles with the petrol to run the vehicle and to run the industries. To get a conclusion, the most populated countries, India and China, are taken as an reference. For simulation purpose, the time series based ANN, that is artificial neural network, along with the Facebook Prophet algorithm is used. Facebook Prophet is used to predict the future situations in time series data related to the oil production and consumptions in two top countries by the population, China and India, over a period of 32 years. Neural Prophet is used for modeling time series based on neural networks, forecasting the near-term oil crisis. The dataset used in this study contains three characteristics, namely population, oil production, and consumption, and is obtained from different government sources. This prediction highlights the need for sustainable energy sources to meet the energy demand in the future. Next, our introduction part. Population growth is defined as one of the major factors for the future rises in oil prices and oil consumption. To forecast the oil crisis accurately, complex procedures are required and artificial neural networks can have the higher accuracy. The accurate article proposes a new artificial neural network based method for time series forecasting called the nonlinear autoaggressive network, which is called as also called as the neural profit model to forecast the oil crisis. The article highlights the need for accurate forecasting methods to address the impending oil crisis and emphasizes the importance of exploring alternative fuels to reduce the dependence on fossil fuels. The data sources that where we have gathered the data are: the major factor of the research paper is population data to be concerned with from our connected from our worldometer and World Bank data. The data of oil production and consumption data from the year 1990 to 2022 of various countries is from US Energy Information Administration, that is called as the USEIA, and CEIC data that are the economic and finance level data. Next, the next is our methodology. First part is our profit algorithm, where the time series forecasting involves using historical data to predict future data sets. To make accurate predictions, it is important to identify and account for the various patterns represented in time series pattern. Artificial neural network can be used in different time series prediction models. The main aspects of artificial neural network where it uses nonlinear data series are sales forecasting and financial forecasting. Here, profit is used to analyze the high level complex data by taking high volume of different parameters. The neural profit takes required inputs as per the selection. Then the model simulates the values, validate it, and gives the appropriate result after proper testing. It also ensures that the model never goes to underfitting or overfitting conditions. Now, the next part is our forecasting accuracy. It is important to carefully validate and test the model to ensure that it is not overfitting to the training data and that is capable of making accurate predictions on new data. Cross validation techniques can be useful for this purpose. It can emphasize on the error calculation by using root mean square error or normalized root mean square error, that is NMSE. Next, our methodology, where our proposed flow diagram are there, where first of all we have taken some inputted data. From that inputted data, the training and testing will be done, and if only training and testing will be done, then the result is unsatisfactory. For that, we have again checking this our normalized mean square error. Then after, the model is going to be satisfactory, and after that satisfactory, the prediction the output model are going to be find out. Next is our, it has been described below. That is the step flows are, first of all, the data are going to be collected from the desired sources. Then the data are pre-processing by cleaning, filtering, and transforming. Then the transferring the data into a format that can be used by a neural network or other forecasting model. Next is normalized mean square error that checks for the validation for selecting the appropriate input variables. Next, the model is validated by analyzing through the appropriate input architecture. Next, a train test and validation of data. And finally, the targeted output has been achieved. Next is neural profit uses both open loop and closed loop features of the model to predict the better, that is the multi-step ahead manner. The open loop features is up to the training stage, then it transfers the trigger to the closed loop for the predictive value analysis. This approach is commonly used in time series prediction tasks where the network is trained on the historical data to make predictions about future data points. Next, our result and discussion. The performance of a neural profit is as the performance of NARNet, that is nonlinear autoregressive neural network during the training. The network launched to minimize the error by adjusting the network parameters. Next, the NMSE, that is normalized mean square error, is generally used to detect the error in the model to do the appropriate approach. It divides the mean square error value to the variance of the actual output. NMSE is a powerful tool for error calculation and is commonly used in comparison with the other models because it is normalized by the variance of actual output which makes it easier to compare the performance of different models of different datasets. Production of petroleum must be greater than the consumption part of the petroleum. That means if production will be greater than consumption, then only situation can be handled. Next, this is our prediction of population for both the countries, that is India and China, and we have collected up to 2040 data. Next, the next is our the figure 3. It depicts as the oil production of referred countries with respect to the time. And the next figure 4 has detected as the oil consumption of referred countries with respect to the time. Next, according to the analysis of for the figure 3 and figure 4, by the end of 2050, the consumption rate will be very high as compared to the production rate of crude oil of these two countries. This will create problem for the overall economic growth of the country. The cost of petroleum production has been increasing due to various factors, including the growth of population, the limitations of current extraction techniques, and the increasing demand for cleaner energy sources. As the cost of petroleum production continues to rise, it may become economically feasible for alternative energy sources such as hydrogen fuel to become more prevalent. However, from the predictive analysis, it concludes that the use of alternate fuel such as hydrogen fuel may be useful around 2040 to 2050. Next, the part of our conclusion. The overall result shows that petroleum will no longer available for the future generation. India and China results shows that how the world is moving. So if it will consider all the countries, then it is out of imagination. There are several resources available which can replace the petroleum, that is maybe hydrogen fuel is an replacement. The research shows that the future scope is to concentrate on the suitable alternate fuel and if possible go for the hydrogen fuel as an alternate fuel which can be substitute petroleum. These are my references and thank you. Okay. Hello.
Yeah. Am I audible? Hello?
Yes, sir.
Yeah. May I know, what did you consider the historical data for your study purpose? In which year?
Sir, basically, as it is an basically it belongs to the analysis purpose, sir. That means here we have not compared anything and we are only used for the regression model where we have analyzed that as within that future, that is in that 2040 to 2050, it may happen that the crude oil or the petrol, it may be finished so that the hydrogen fuels, it can be used by the people for both the country, that is India and China, sir.
That's okay. I wanted to know what was the last year of the data, historical data that you say. In which year you have considered it for your prediction?
Sorry, sir, your voice is not audible, sir.
You say that you have considered historical data for training.
Okay, sir. Yes, sir.
So which is the last year
Ha.
of consideration of that historical data?
Sir, in 2022, sir.
In 2022. Okay.
Yes, sir. Yes, sir. We have collected from 1990 to 2022 data, sir.
And you say that to see that it is not underfitting and overfitting. What are the conditions that is expected for underfitting and overfitting?
Sir, actually underfitting sir, actually both the cases, that is underfitting and overfitting, that are not suitable for the predicted output. It is only good for the best fit. So whatever the model we have used in our network profit model with the help of artificial neural network, so in this case only the best fit is achieving, so that there is no such any mistakes or any type of errors, it cannot be mismatched, sir.
And whatever we have come across the MSC and NMSC.
Sir, these are the error calculation techniques where after finding the by the help of training and testing, by the help of our Facebook profit algorithm, that mathematical model has been taken out by a normalized mean square error. which is something better than the our root relative square error, sir, so that the error can be achieved properly and the error can be minimized, sir.
So what is that error that you got and what betterment you have?
Sir, the error is that whenever at the year of 2040 to 2050, as the two countries, that is India and China, whatever they are just hiking their that means whatever they are the rate they are using the petroleum and fuels, so that it will be finished. And after by the help by implementing this Facebook profit algorithm, it gives that by the year 2040 to 2050, the fuel it may be finished in our earth.
So what are your suggestions, your recommendations?
Sir, sorry, sir.
What are your recommendations?
Sir, our recommendation is to better if we will use the hydrogen fuel instead of petroleum fuel, because hydrogen just only gas only.
That is the only recommendation or something else?
Sir, that is our up to now we have concluded this, sir. That means that our analysis. It is that is our analysis, sir.
Okay, fine. Go to the organization.
Okay, sir. Hello.
Sir, any questions?
Hello.
Hello.
Yes, sir. Your voice is audible, sir. Yes.
So, except this artificial like as a model.
Sorry, sir. Voice is not audible, sir.
What prediction models you have used for your work?
What prediction models are used for your work?
Okay, sir. We have used our regression model, sir.
Which models?
Sir, regression model, sir. It is a non-linear regression model, and that model and that algorithm name is Facebook profit algorithm, sir. Non-linear regression model, and it is Facebook profit algorithm.
Can you name the regression model which you have used?
Sir, sorry. Sir.
Can you name that algorithm model?
Yes, sir. It is Facebook profit algorithm, sir.
Okay, so single model you have used or any other model you have tried?
You used only single model or any other models you tried?
No, sir. We have only used that single model.
How can you be sure that this will be the only better accuracy? You have not tried other models?
Because sir, as we have used that single model, and after that single model implementation in both the training and testing and along with our validation purpose, then whenever we want to minimize the error by the help of by the help of this NMSE, that is the normalized mean square error, then it has find the better output, sir. That is why we have used only this Facebook profit algorithm.
Okay, but regression model, there are a number of regression models which would be better for you only unless you are not trying it. You cannot be sure enough that this is the only model which can give you better accuracy.
Sir, sorry. Hello. Hello. Hello.
With a single model, how can we trust the presentation? Actually, we need to try number of models, then we can get to know which is the best one.
Sir, actually, sir, our work has been based upon the analysis only, and by the help of that Facebook profit analysis and whatever the output that model has given, and according to that analysis only, it says that around to the 2040 to 50, the petroleum fuel or the petroleum fuel it may be finished, and then after it can be go for the hydrogen fuel, sir. It is not for the comparison. That means we have not do any type of comparison models. We have only done some of analysis work.
Okay, thank you for presentation.
Okay, sir. Thank you, sir. Can I leave now, sir?
Yeah.
Okay, sir.
Next, we will move to the next presentation. Paper ID 130.
Sir, hello, good afternoon, sir.
Yeah, good afternoon.
Can I share my screen, sir? 130 paper number.
Okay.
Sir, hope my screen is visible, sir.
Yeah, it is visible.
Okay. Okay. Good afternoon, all of you. First, I would like to thank the organizers of the conference, and then review members, TPC members, and then session chairs. Okay. Today, I'm going to present our work, FedRH, Federated Learning Based Remote Healthcare. Myself, Sachin. My co-authors are Professor Anappa B, Satish Sambisenge. I'm a research scholar, Department of CSE, NITK Surathkal. Okay, so here we are going to solve data privacy issues in healthcare data. So the overall abstract about our work, the first thing is after the COVID, the health monitoring is a growing field. So a lot of apps, the mobile health apps, and then a lot of healthcare devices are in the market. Okay, but the major challenge also, for example, every day we are using the smartwatches, and then smartwatches, the BP monitoring devices and sensors, and then we are using fit bands, and then different types of healthcare devices we are using, and then ECG monitoring devices and everything. Okay, so the one before COVID, so not that much that much focus on our health. After COVID, everyone regularly visit the hospitals, and then monitoring the health is the common trend. So after COVID, so but the one major issues here. So we need to push all the data to one centralized location. For example, if I visit some X hospital, so again, I'm not satisfied with that one. I will go to the Y hospital, but the data will be silos in a X hospital and then Y hospital. So both data we can't combine. So then one thing we are generating a lot of health related data using the IoT devices, and then the new sensors available in the market like that. Okay, so then one thing we regularly we need to visit the hospital. So to cut down that one, so we can integrate the A with the IoT devices. So the lot of already the proven results are available. So we can regularly monitor monitor the AA based healthcare application like that. So here again, one problem will arise, the data privacy. So to predict the sequence of the future sequence, so we need to train the model in centralized server. So we need to move all our healthcare related data. For example, if I am using the smartwatch, I need to move my data to Apple, the service provider like Apple or Samsung like that. Okay, so for example, if I visit some hospitals, my data will be stored in the hospital. The hospital want to build some disease prediction models. They need to move all the data to their server. Their server in centralized thing. So we need to, the first thing is we need to move all our health data to centralized device to build the AA model. So the data privacy will play the major role here. So that's why we propose the FedRH. So without moving data, so we can build the AA model. So then we compared the centralized devices, centralized training, and then federated learning training. So we achieved the better accuracy compared to the centralized training. So again, some problems are there in the FL also. I told, so we can integrate the AI with the IoT devices. We can get the better healthcare, and then doctor can analysis better compared to the normal things. So some major issues are here, regulations. So for example, we can't include all the healthcare data. Why? Because some laws, GDPR, and then IPA will break the scale down breaking the scale in the healthcare application. So we can see, so a lot of healthcare apps available in the market, but then may not scale. Why? Because of this regulation. The another one is the user preference. Maybe for example, I am using some smartwatch like that. I may not give my healthcare data. Then another one is the data volume. We can't push all the data to the centralized servers. Then again, the scalable issues. We can solve. Okay, so instead of moving the data to centralized server, we can train in the edge devices using the federated learning. We can solve. So again, in federated learning also a lot of challenges are there. I will explain what is the federated learning like that. So before that, I will explain my problem. So this is the motivation for doing this work. For in our lifetime, I will visit the multiple healthcare entity. For example, I am using some mobile apps, healthcare mobile app monitor from daily routines. And then, for example, when I sick, I will visit the hospitals. In childhood, I will go some laboratories to scan my, for example, MRI or something like that. Okay, so if I access all the data together, so I can monitor my health, or doctor maybe monitor health, or my AI model can monitor better. But now in current situation, we not access our own personal data also. For example, if I use the smartwatch, the Apple smartwatch, if I am using the Android smartphone, so we can't club the data. We can't club the data, and then I can't integrate my smartwatch in my Android devices also. So this is the major issue. Now our all healthcare data is stuck in the data silos. Data silos means my data will be stuck with Apple server, or my data will be stuck with hospital, X hospital. My data will be stuck with some Y hospital, and then other laboratories are like that. Okay, so how we can access all this data knowledge, and then we can build the better healthcare monitoring. So with solving this issue, one, we can do the scalable healthcare application. So another one is we can utilize our edge computation. The major issue we can solve the data privacy here. So then these are the methodology. So here we use the federated learning. So what is federated learning? The federated learning will so in normal centralized training, we move all the data to train the AI model. All the data we will move to the centralized data center or cloud to train the model. So here in FL, for example, FL server will connected all the edge devices, all the edge devices. So in here we can connect all devices like our mobile, our smartphones, and then our IoT device directly, and then else our hospital servers, and then which one our healthcare app servers, and then laboratory edge devices like that. Okay, so instead of the data will be generated at the edge. So instead of moving data to the server, so here we generate the model in the FL server. We move the we send the model to all the edge devices. So then what edge devices will do, edge devices will train their model using their local data in edge devices itself only. So then each edge device will send the updated weights to the model, updated weights to the server. What server will do? Server will aggregate all the updated weights, and then all the updated weights from the clients, that will update the model, new model. Then again that will send to all the edge devices. So again, edge devices will train their local data using model. Then again, the updated weights will be sent back to the server. So here, the data will be remain safe in the edge devices only. Then only the model parameters will be move to the server. So then this process will be the FL. We call as FL rounds. The FL rounds will be repeated until we get the desired accuracy. Else the model will be converged. So here, what we are solving. So my data, for example, data will be stuck with one client device also, and then client 2 also. For example, I am using the smartwatch, and then client 3 also. So here the same, for example, either assume the 4 clients are participating in this particular round. Okay, 3 are very actively physically fit. Okay, so every day they will do the fitness and the healthy diet and like that. Okay, so then 1/4 is not actively fit, and then not maintaining the good diet also like that. So that time we aggregate all this and then build a global model, so that may not predict accurately for the fourth one. So that's why we include the personalization things here, the personalization for the particular client like that. So that's why we incorporate the retraining mechanism. So once the model sent back to the server, so again, before access to the client or something, some applications, so we retrain the newly updated some percentage of data. So then we can use the model. So that time the local flavor will be remain same. So just like how after dinner we add the dessert, so the dessert flavor will be is there in the sometime. So compared to the first dishes we add like that. Okay, so the in which one? Local the retraining mechanism we incorporate here. So this is the model. We just incorporate the hybrid LSTM CNN and LSTM model. That's it. Not a normal model only to train these things. So here we mainly focus on the federated learning process instead of building the model. Okay, so these are the overall learning process. Learning process is just like a normal Fed. We incorporate the Fed average. That is the first federated learning algorithm proposed by the Google team, and then we incorporate the retraining mechanism here. So once the model is updated, so again the retraining with 1,000 data samples. So we vary this with the 10%, 20% of the data also. So then. So here, the one thing, so we incorporated the homomorphic encryptions, the other than Fed average I'm talking. We incorporate the homomorphic encryption to protect the model parameters from client and server. So then we tested in the real environment only. So the most of the work they focus on the simulation only. So here we use the ML dataset. The ML dataset is a human activity recognition dataset. We tested only one downstream task, the human activity recognition task. So then it's contained the 10 users data, the 12 classes, the 12 activities. 12 activities and then recorded using the three sensor. So here we divided 8. We kept 2 for the testing, 2 users data for the testing. We divided the remaining 8 users data. We combined, we shuffled, and then divided into the 4 clients. Divided into the four clients. 4 clients. And then we run this experiment for the 100 rounds. So we run the different 3 up to 500 rounds. But after 100 rounds, the accuracy will be stable. We did not move like that. That one. So then we built using the Flower framework. It's a federated learning framework, and then with the TensorFlow. So here we run this server script, the server script in the AWS EC2 virtual machines, and then we connected 4 clients with the local system, local Linux systems, and then we kept data in the local thing only. So and then we run with the different epos, and then we record the time taken for this one, time taken for the different first also. So the one major thing is, so we run with the we compared with the classic ML algorithm also. So individually, so these are the 4 clients, client 1, client 2, client 3. We record the difference. So why this variation in between the clients also? So we shuffle the data, data. So that's why based on that one, the difference is there. So here, then we compared with the 2 FL state of the art, which one FL algorithm also, the FedDome and then FedHealth. So here the compared to the FedDome FedHealth, so our proposed thing will be communication round is less, but computationally it's a burden. Why? Because we did the retraining, that's why. So it will take the computational things, but the communication we reduce. And then we tested with the centralized things. Okay, compared to the centralized things, so the more than 5% the accuracy will be improved. So then another one interesting, thing is, so this is the comparison of the one client out of 4. The first client's the confusion matter. This one, hello.
Please conclude in 2 minutes.
Yeah, okay, that's fine, sir. I will tell. So here, now the misclassification is more in the centralized thing. So here you can see the misclassification also less. So then the conclusion is, so here we can solve the data privacy issues using the federated learning also. And then so then the future extension of this work. So we can now we are testing with a different downstream tasks like ECG classification, then with under image data set also, eye retinopathy. These things also, we are working on that one. And then here the personalizes thing, the retraining mechanism is computationally burden. So we are testing the different personalized techniques like knowledge distillation, transfer learning. So different things we are exploring this one. And then so here we use only the simple data set, human activity. Thank you. These are the.
Sir, any questions?
Yeah, hello, audible?
Yes,
Yes,
sir.
sir.
You are
Thank you,
audible.
sir.
Yeah, this is your work of FL. You
Yes,
said
sir.
every devices are considered.
Yes, sir.
For how many different edge devices you have worked with?
Sir, here we use the 4 edge devices with the same capacity only, sir. That's why I told we did not test on the heterogeneity. Actually, we initially we planned with the test with some and include the Android devices also. We converted that model using the TF Lite for the Android also. But some issue with the pipeline connecting with the Android Studio. Sorry, in Android Studio we need to include some pipelines, the Kotlin pipelines.
Okay, fine. Now, you say that on these edge devices, the training is done onto the local data. Fine. And after that, once the training is done at the local end, again you collaborate them and get at the federated server. Where have you come across any kind of duplicacy of the data? Hello,
Mr. Sachin?
I hope you have an answer. Hello, hello, Sachin. Hello.
Hello.
Have you come across any duplicacy of the data?
Sorry, sir.
When you train this onto the local data,
Yes, sir.
after that you again collaborate it at the federated server.
Yes, sir.
Again you retrain it.
Sorry.
So do you need that retraining phase? Have you come across any duplication of the data?
No, sir. No duplications.
And why did you come up with this homographic encryption here? What is the purpose?
Sir, we just include because of any manipulation between the client and server. It may be, for example, assume if there are any changes in the parameter of the one client, that will affect the overall model, sir. That's why.
Okay. Fine. Go to the
sorry, sir.
Yeah, go to the right.
Sir, any questions?
Okay. Hello, sir.
Can you hear me?
Yeah, yes, sir. So, but voice is very low, sir.
Okay. So,
yeah, tell me, sir. Now it's audible. Sir.
Main contribution of your work seems to be use of federated learning for
federated learning plus retraining mechanism, sir. Retraining things.
Security issues in remote healthcare you are trying to address, right?
Yes, sir. Yes, sir. And then another issue is the data island. In the normal federated learning, they use the one type of device. For example, that will work for only the mobile app servers. Else, only hospitals, the only devices like that. Here, we need to integrate all the things, sir. All the things. For example, my data will be stuck with a different 2 to 3 data island. So that's why we shuffle the data and then we put it in the different things.
But I didn't see any in your result part, the security aspect, how it is improving, that I didn't see in your result part.
Sir, just a minute. Sorry, here you can see, sir, it is centralized training. Centralized training means it's a no security of the data. So we move complete data to the centralized server. Here, data we did not move data to the centralized server, sir.
Okay.
It's a complete data in this one C1, C2, C3 is edge devices. The data will be remaining in the edge devices only, sir. This one we tested in the centralized single system. This one we tested in the 4 systems.
Okay. So have you tested this model or implementation? Have you done in the hardware or somewhere?
Sorry, we tested when the server we hosted in the AWS EC2 instance. And then at devices we use the normal systems, sir, the i7 processor systems. So actually, we are working. We are testing with the combination of different devices, Android devices, embedded systems like that. We are extending that one.
So which data you are using? Public domain data? Or
public data only, sir. ML dataset, public dataset. We used only. And then we tested with only one type of task actually. So now we are doing the different use cases and then different personalized techniques and then different types of environments, heterogeneous environment like data heterogeneity aspects and then system heterogeneity aspects also. Okay. We are extending that one.
Oh, thank you.
Hello, sir. Hello. Okay, thank you, sir. Thank you so much for the inputs.
Okay, thank you for presentation.
Okay. Thank you, sir. Thank you.
Sir, one more. 48 no. Hey. Please confirm who is presenting paper ID 48.
Hi, hello, my name is Shravan. My voice
Okay.
audible?
Yeah, you're audible. Okay, you can share your screen now.
Screen visible?
Yeah, it is. Yes, sir. Yeah, it is visible. You can present now.
Good afternoon, everyone. So my name is Shravani. So we have made a research paper on the topic fire sharing scenarios. So this is the outline we'll be going through today's PPT. So that is introduction, the problem statement, the objective we have, the concepts and methods, the tools and languages that we used, the architecture, implementation, and then with a conclusion, we can see the results. So moving to PPT. So in today's technological world, like making devices share, sorry to interrupt, basically my laptop charge is very low and I have a power cut at my home. So if there is any issue or disconnecting, can I join through my phone?
Yeah, you can join.
Yeah, thank you so much. Sorry to disturb. I'll continue. In today's technological world, like making devices share is very much super important. So we are going to look at 3 different ways that this can happen and figure out which is going to be the best. So imagine it's like finding the perfect balance between making things easy and keeping everything super safe. So we'll go through each and every way, like how to make it simple and how to set it up and how to keep it secure. So the big goal here is to have a smooth system where data moves easily between various kinds of devices, different devices, but at the same time, making sure its security is also at the base level and it is safe and sound. So let's dive into it and see how we can create a setup that is both easy to use and which is very much super secure for sharing the data among the various devices. So the problem statement is our paper's aim. The challenge at the hand is to develop a system for multi-device sharing. So sharing that harmonizes user friendliness with robust security. So with the increasing dependence on interconnected devices, finding the right balance between simplicity and safeguarding the data integrity possesses a central dilemma. The problem is to create a tailored solution that facilitates seamless data flow across diverse networks and subsets while ensuring stringent protection of data integrity and confidentiality. So this requires a nuanced approach that addresses the specific organizational needs inherent in multi-device data sharing complexities. So this is the objective to support various data sharing scenarios and data security and regulatory compliances. So the concepts and methods, that is VPN, network address translation, subnetting and VLANs, scalable and cost-effective resource allocation, and block storage. So these are the tools and private cloud, Microsoft Azure, block storage, and Python for creating UI, Flask extension and libraries. So, and Python anywhere. So let's jump into the process and architecture. So in this paper, the architecture handles 3 scenarios of data sharing, namely devices connected with different networks. In this scenario, the devices are connected to a shared blob storage system, which can be accessed by the allowed devices. To access this data, a web application is designed to connect the devices to storage for seamless data storage, upload and download experience for the device user. This is the devices connected to the different network. And next is the devices connected to the same network but different subnets. For this, we will configure the subnet and assign IP. And within the virtual machines with same virtual network and mount the VM within the storage. By mounting the storage, the devices can access the data as if they are stored locally. Next scenario, and this is a similar to the second scenario, except that we'll configure the virtual machines with the same network. Okay, and this implementation, that is VPN to VPN data sharing. And so this is the interface of the web application. So which will allow us to upload a Azure Blob Storage. And this is the second interface which we'll be going through. That is a web application, and this displays a list of files that will be currently stored in the storage. And this is the third interface of our web application, which provides a search field where we can enter the name of the file, whatever we want to download it, and then we can download. So we have provided with the screenshots of our implementation tool. So one is which provides the information about virtual machine called the host, and the other one is the figure 8.5 is a screenshot which we have attached, a file from the desktop with the login ID, which will be passed into the network, and it will be shared with a drive name called FTP. So these screenshots are the 8.6 will display the details about another virtual machine, which will be named as the teacher host. And the figure 8.7 is the network shared drive name, so which is FTP, will be accessed over the network and which can be used to retrieve a file that was shared by the host virtual machines. So, sorry. Yeah. So this is, we have come to the conclusion. That is, the proposed private cloud architecture offers benefits such as data sharing, flexibility, scalability, improved collaboration and productivity, but we must have the limitations such as network infrastructure, deployment, complexity and cost. So the future scope involves enhancing and fine-tuning of data sharing capabilities to foster seamless collaboration, and the RBAC can streamline data sharing process and ensure secure access to shared resources. So Azure platform services such as Security Center, Firewall and Key Vault offer robust features to enhance the security and regulatory compliances. Yeah, thank you.
Ms. Ravani, please go to results slide.
Is this one?
Yeah.
Yeah, actually, so, yeah. Is it visible now?
Yeah, it is visible.
Yeah, actually, there is a video of our implementation. So
Okay.
am I allowed to play it?
Yeah, you can play.
So basically, this is the screenshots that we attached with the PPT. So we can upload our file. And here from we can also download, and we can select the files and it will take the host. So we created by using Flask server to create, and we have used Python Anywhere to host it.
Sir, any questions?
Hello, am I audible?
Yes, sir, you are audible.
Yeah.
We have seen for various scenarios of file sharing. What is the one which is suitable for which purpose? Hello?
Sir, you are audible.
Yeah. Out of the scenarios of file sharing, which one is suitable and for what purpose?
Ms. Ravani, are you there?
Hello?
Hello, Ms. Ravani.
So you are saying that
Yes,
laptop will be,
yes, sir, she disconnected. Sir.
yeah. Let's wait for a while.
So let's wait for 2 minutes. Sir. She may.
She may come back. Yeah.
Yes, sir, no students are there. Yes, sir. Sir, please send the evaluation sheet to my mail, sir. I sent them a request mail to you.
Yes, sir.
Sir, regarding here, we need to choose one best paper out of these 5 papers.
Hello? Patil sir.
Yeah.
Good afternoon, sir.
Good
Yeah, Anurag here.
Yeah, fine.
So, sir, I think as per the evaluation sheet given to us,
Yes.
we need to recommend one paper for best paper award, I guess.
Yes, sir. So in my view, I feel it is ID number 130.
130.
Yeah.
Yeah, exactly. I'm also conversing on the same. So I'm also recommending that.
Fine, sir. Okay.
Federated learning for based remote healthcare.
Yes.
Okay, sir. Thank you. Okay, sir. So I will on this physical hard copy. I will write that and give hand over it. Okay.
Fine.
Okay. Thank you.
Sir, please send the copy to my mail, sir. I sent the request mail to you.
Yes, sir.
Okay, sir. Thank you, sir. Yes, sir. Thank you, sir. Thank you for joining us.
Yeah, I hope she will not turn up.
Sure, sir. Thank you, sir.
Yeah, we will end the session.
Sir?
We will end the session. Or
Yes, sir. Yes, sir.
Okay, fine.
Sir.
Okay, fine. Thank you.
Thank you, sir.
Hi, sorry, I got disconnected.
Hello?
Hello.
Is Miss Shravani?
Yeah.
Yeah, just a moment.
Yeah, okay.
Hello?
Yeah.
Yeah,
Hello.
yeah, sir left the meeting. It is okay, no issue. You can leave.
Okay.
Okay,
Okay, thank you.
thank you.
Hello, Mr. Sir, Sir Jagannath sir. Sir, am I audible, sir? Hello. Jagannath sir.
You are audible. You are audible.
Sir, I'm audible, sir. Sir, if you agree, sir, our internal sir is absolutely yes, sir. If you agree, sir, can we start, sir, presentation? Sir, he disconnected. Hello, sir, Jagannath sir.
Yes, sir.
Yes, sir. Sir, shall we start, sir, presentation?
Yes, yes, sir. Yes, sir.
Yes, sir. Okay, okay, okay. Good evening to all of you, sir. Here I am Mohammad Kashif Khan, and we are here to celebrate second IEEE International Conference on Blockchain and Distributed System Security of 2023. And here we have the internal sir, Dr. Vinay Kumar from IIIT NR Department of Computer Science and Engineering, and the contestant who are here to present the paper. So please hear the external sir, the external chair of our person is Dr. Jagannath E. Nalwade, distinguished computer scientist with a strong background in academia and research with a PhD in computer engineering and from Valtech Rang Rajan. Dr. Sangutla, R&D Institute of Science and Technology from Chennai. So all of your contestants who are here, you have the guidance, strictly guidance, you have 10 minutes. You have 10 minutes to present your paper and 5 minutes for Q&A from the external person. External sir, you have 5 minutes for Q&A and 10 minutes for present your paper. Am I clear, all of you? Hello?
Yes, sir.
Yes, no? Okay. So here, sir, shall we start, sir? Sir, okay.
Jagannath sir, welcome
Yes, sir.
for
Thank
the
you, sir.
presentation. Thank you very much for joining.
Yes.
Okay, okay.
Yes,
Thanks.
thank you. Yeah.
Okay, we can start.
Yes, sir. No, sir, sir, I will. Okay, sir, okay, okay. Connect. Okay, so we have the paper ID 110 utilizing correlation analysis for validation of image datasets in lower spine diagnosis. Who is the paper ID 110? Paper ID 110. Okay, okay. So shall we next? Okay. So the next paper ID 42. For paper ID 42 is here.
Yes, sir. Paper ID 42.
Artificial intelligence enabled disease prediction
Yes.
system in healthcare industry. Yes.
Yes, sir. Yes.
Okay, okay. So you have 10 minutes to present yourself and 5 minutes for Q&A. Okay.
Okay, sir. So shall I share my screen?
Yes, sir. Yeah, sir. You share your screen. Okay, and please start your video, and other of your mate who involved in this project, please tell them to open their camera and unmute themselves. Okay.
Okay, sir.
Okay. Please open your camera and present your presentation, please.
Is my screen visible to all?
Yes. Yes, please start, sir.
Okay, so good evening, everyone present here. My name is Diksha Onyal, and I'm pursuing my BTech Computer Science from Graphic Era Hill University. So my paper ID is 42, and I am here
on behalf of my team to present my project. So basically, the main aim of our project was to resolve the problem which most people are going through in the healthcare sector, that basically we want to provide an artificial intelligence to help doctors and patients to predict accurately that which disease are they going through. Here we are basically collecting data from various patients, and we are training our model. We are training our model to predict accurately. So for that, we are using some ML models like SVM, support vector machines, decision trees, random forest, and for and here also we have divided it into two parts. Like for when the patient will input their symptoms in the form of text, we will use ML model.
Hello, Diksha. Diksha.
Yes. Yes.
Please open your camera, please.
Okay.
Okay. Okay. Please continue.
Sir, am I visible?
Yes, you are visible.
So basically, we have divided it into two parts. So basically, the patient will input text in the form of symptoms, and we will use ML model to predict if he is going through the disease or not. And second is image. We will use images like CT scan, MRI, and we will use CNN models like RESNet and DenseNet to predict if the patient is going through that disease or not. So it requires several steps. First is the data collection, means we collected data from various resources like Kaggle of healthy and sick people. And next is data pre-processing. We are reducing noise like NaN values. We are reducing augment data. We are resizing the image, and also we are rescaling. We are dividing it by 255, and we are enhancing the feature. Now third step is feature extraction phase, where we are training the model. Like for text, we are training it with the help of ML model, and for image classification, we are using CNN models. And fourth step is disease classification phase, where we are analyzing classification based on feature extraction for normal and affected sections.
Diksha,
Yes.
can you full screen your slide, please?
Okay.
Okay. Here, in the corner. Okay, good.
And here is very much importance given to noise removal, because if we won't remove the noise, it can lead to some problems like overfitting, which we came across. And now talking about the results, we got a good accuracy. Like the DenseNet achieved the highest accuracy for image classification with 82.86% on validation accuracy. Means for the unseen data, it received 82.86% accuracy. And as you can see from the table, across like DenseNet, VGG, and RSNet, we applied these algorithms, but most accurate was DenseNet. For text classification, as you can see, decision tree was the most accurate for our textual data, and logistic regression performed very poor in our research. So conclusion is that basically the research in the research we are exploring the potential of machine learning and deep learning for disease forecasting in healthcare, and the final result is determined by selecting the best performing model among various options. And we also took some references from paper who also did same kind of work. Thank you.
Hello, sir. Sir, question? Any question, sir?
Sir, your mic mute.
Sir. Sir, your mic is unmute, sir. Sir. Sir, you are not audible, sir. Can you, sir, unmute your, sir? Rejoin करने को. Sir, shall you, sir, rejoin your, sir, ID, sir, please? Okay, Diksha, our sir, internal sir, will ask you some question. Okay.
Okay.
What is the size of your data? What is your size of data?
नहीं sir, mute नहीं है sir, 100% okay. Sir, सही इधर आइए.
Am I audible?
Yes,
What is your size of data?
sir, for textual or image?
Image
512.
512.
Yes.
512 what?
Image size basically.
No. It should be row and column, no? Okay. What are the attributes of your developed model?
Hello. Am I audible, sir?
Yes, sir. Yes, sir. Yes, sir. Absolutely.
Yes. Diksha, can you go to your implementation slide? Third or fourth slide, I think.
Okay. Sir, methodology.
Yes. You told that you have used a SVM, decision tree, random forest. So where these algorithms are used, and it is not reflected. Actually, in introduction section slide, you told that this type different algorithms you have used. So where it is used and how, what is the use of this algorithm?
Sir, these algorithms are used for classifying and to predict a target value, basically to predict a target value that if this value belongs to this one.
Yes, but all like SVM, decision tree, random forest, all algorithms you have used, or any one algorithm is used for this classification phase?
Sir, we used 3 of these algorithms, and the best performance was for decision tree.
Best performance from the decision tree.
Yes.
Okay. So have you reached to the any collaborators regarding this healthcare data or like this? Can you try to you are is interested to implement this your system in real any hospital or any healthcare institution?
Yes, sir. Basically, our main aim was to improve the accuracy for disease prediction. So, sir, actually, we collected data from Kaggle dataset because these kind of data are not basically not given to students like us easily. So, we have to collect it online.
So you have used the data from the Kaggle website.
Yes.
So that data is up to the mark, or any challenges you have faced to use this particular data?
Sir,
regarding any data quality or any type of the issues are there?
Yes, sir, we were facing some issues, so we had to do data pre-processing. Like there were many NaN values and there were many columns which were not required. The columns were filled with NaN values and we had to delete those columns also.
Which performance metrics is you are used here to check your performance of your system, performance matrices, measures, performance measures. Yes.
Sir, we just like wrote like a model dot accuracy and find the accuracy for each algorithm.
Can you show the last slide, result and discussion?
Yes.
Yes. So in this slide, you have compared the result, your result with the other. So which matrices you are used to compare? Any accuracy and validation accuracy. Only accuracy matrix you have used to check the performance. Am I right?
Yes.
Validation accuracy. What is the validation accuracy?
Sir, validation accuracy is the accuracy the model got by it basically tested on the unseen data. It was encountered with the unseen data.
Okay. Okay, thank you. Thank you, sir. Yes.
Sir, yes, sir. Sir, shall we move now, sir? Shall we move for another participant, sir?
Yes, yes, sir.
Okay.
If
So,
internal, sir, they want to ask any
sir, yes, sir, yeah, he is coming.
Yes, sir, we are to the next participant because I have already asked the questions during leaving the meeting.
Okay.
Okay, sir. Sir, we moving now, sir. Okay.
Yes, sir.
Okay. Diksha, can you please close your slide, please?
Okay, thank you, sir. Thank you, everyone.
Thank you. Okay.
Yes, yes, all the best.
Okay. The paper ID 110, is he here? Is he or her present here? Paper ID 110. No. Paper ID 234. Paper ID 234. Paper ID 146. Is anyone present here? Paper ID.
Yes, sir. Good evening, sir. Paper ID 146.
Paper ID 146. Okay. It is it maximize throughput of emergency data in W-band using machine learning? Is it?
Yes, sir. Yes, sir.
Okay. Please open your camera and the participant with you in your group. Please tell also them for open the camera and unmute yourself. Present to the sir, external sir. Okay. Open your camera first.
Sure, sir.
Okay. Start. Dipshika, you have 10 minutes to present yourself and 5 minutes you have for Q&A, okay?
Okay, sir.
Okay, start.
So is my screen visible?
Yes, it is. Is it visible? And please full your side, sir. And a slide.
Is it okay now?
No. Complete. Big screen, full screen your side. Slide.
Okay. Wait a second.
Okay.
Now is this visible?
It is visible. Can you full screen your slide? Press F.
Is it okay?
Yeah, it is okay.
Okay, sir.
Nice.
First of all, good evening, sir. Good evening, everyone. My name is Deepshika. I'm going to present my paper, Maximize Throughput of Emergency Data in WWAN Using Machine Learning. So here is a table of content. In my paper, I have in abstract introduction, literature survey, research gaps, methodology, results and discussions, conclusion and future scopes. So I'll start with the first thing that is abstract. So actually, basically, wireless body array network has increased a lot of attention in today's technology. So the most difficult challenge for WWAN is to handle diverse traffic in network with limited resources. So in this research, we found that data delivery with less loss and delay may not be accepted. So hence we use the use of intelligent algorithms to deal with these systems is required. So as a result, to improve the classification accuracy, random forest and support vector machine classifiers are used. So these are two machine learning algorithms. So this approach is to charge of determining the class of incoming packet and assigning a priority to it. So we worked on three matrices, that is throughput, end-to-end delay, and packet delivery ratio. So these I worked on these three matrices. So at the end, I found that SVM provides high throughput. So when we move to introduction part, here is IEEE 802.15.6 is the first international WWAN. It's a wireless body array network that supports communication inside a body. So basically, WWAN is a wireless network of wearable devices. So if we talk about it, is a basically network containing sensors that are attached to human body, used to measure biosignals, just like heart rate, blood pressure, temperature, okay, of humans. So basically, it is categorized in three categories: normal data, emergency data, and on-demand data. Next is monitoring sensors. These are the sensors, just like we have two types of monitoring sensors. First is wearable and second is implanted. So wearable sensors, we also call it as on body sensors, means that sensors that we planted on the surface of body. For example, if a person wants to check their blood pressure, we have machines for blood pressures, ECG. So that sensor we planted inside on the body, on the body surface. So implanted sensors are like that, are planted on the close contact to the skin, just like if we want to check the diabetic patients reports of that, we have we use injections, we use insulin, we have. So these are means that go inside the body, so that are implanted, means in body sensors. Next is, these are some vital signals, just like temperature is used, vital signal, and this is measured by the sensor thermometer. Activities in muscles, it's measured, is sensed by EMG. Skin diseases are measured by or sensed by galvanic skin responses, just like diabetes are measured by gyroscope insulin actuator. Just like blood pressure or hypertension is measured by blood pressure sensor actuator. So these are some vital signals, and we measure, we sense there are some sensors that are used to measure those vital signals. And then we come to the next part, that is application. So wireless body area network is used in medical as well as non-medical fields. So if we talk about medical, it is used in diabetes, asthma. In non-medical, it is used in sports, entertainments, and so many other places. So when I come to next point, that is literature survey, I found some papers and I found some research gaps. By studying those gaps, I tried to optimize some things. So this is the first paper that I study, that is uh, in this paper I found that this is my base paper also. So in this paper I found that author worked on these WWAN wireless body array network, but it found that critical and emergency conditions need urgent responses by healthcare persons to take correct actions and cure the patients. So they worked on classification of data in WWAN and solving multi-class classification problem. So in this paper, author used machine learning algorithms as a fusion of two algorithms, support vector machine and binary decision tree. So for data classification, they identify the actual class of packets. So in this, the category, that packet is divided into three categories, like real time, on demand, and normal packets. But they didn't work on emergency data. They identified the things but not properly. This is my second paper. In this paper, author found that they proposed various machine learning algorithms, methods for classification and prediction of data. So some of machine algorithms they used as like support vector machine, decision tree, KNN to classify the data and improve the accuracy. Uh, Next is this paper. In this paper, author found that ECG diagnoses heart diseases. It shows thousands of different types of beats in a single ECG. So basically, they classify those beats depend upon the signals. Author used different machine learning based algorithms for classification,
Deekshita, hello.
and these are
Hello, please
four
make it
vector
fast now.
machine.
Okay. Make it fast. Make it fast. Make it fast. Okay.
Okay, sir. So these are some models. This is a literature review table. This table shows that there are various authors. There were various research work is done on these things. These are the research gaps I found. I found a lot of work is already done on normal and emergency data, but work is done on emergency data, but to achieve maximum packet delivery in critical or emergency situations is not done properly. So also they work on the packet delivery ratio. It consumes more energy, but less number of packets are delivered. So I found some of the research gaps. This is a methodology. The first step in the methodology is the initial stage is the collection of data from UCI repository, and then incoming packets are fed into alerting units. These alerting units identifies the data by monitoring sensed value with actual range value. After that, I take machine learning algorithms like SVM and random forest for classification of data, where it is whether it is normal or emergency. So if we found that data is emergency data is identified, then we send that data to priority basis. Last stage is analysis of data. So this is a flow chart. So it shows the points. Means first is a selection of scenario. We select that scenario from where we use things. After that, we initialize the number of nodes. Then we are defining the protocol. After that, we implement those algorithms, random forest and SVM algorithms. After that, we find out the malicious node where emergency occurs, and then we analyze the performance. We analyze these things: end-to-end delay, packet delivery ratio, and throughput. So these are the algorithms that I use: support vector machine and random forest. So these are the results. Our first thing is throughput. Throughput is basically in less time, more number of packet delivered with less loss. That is throughput. So in this result, in this graph, I found that this red arc is for SVM, this green arc is for random forest, and this blue arc is for without classification. If I see these things without classifying these things, so that is very low. But by seeing this throughput, random forest is good, but support vector machine is most good. So this is end-to-end delay. End-to-end delay is a delay that from one point to another, from source to destination, there is no like it takes less time and complete packets are delivered. So this is a packet delivery ratio. It shows how many number of packets are delivered from source to destination. So these are the some of the results. Here's a conclusion. In the conclusion, I showed that I use a network simulator NS tool to simulate these events for sending, receiving the packets. So I use these two algorithms: support vector machine and random forest. So for the classification, to perform the classification unit in WWAN. So the simulation is suggests that proposed classifier is capable of reducing end-to-end latency and increasing packet delivery rate and throughput in the healthcare WWAN system. So basically, in this, I found that end-to-end delay is less and packet delivery ratio is more. So these are the future scopes that I'll try to implement these things with using new AI algorithms in future, and also we try to find out new patterns to investigate hidden patterns from this research. So these are the references. Thank you, sir.
Sir, any questions? Sir, any questions? Sir, your voice is not audible, sir. Hello. Sir. Sir, your voice is very low, sir. Your voice is not coming here, sir. Hello, sir, your voice is not coming here. Your voice.
Hello.
Yes, sir. Yes, sir. Yes, sir. Yes, sir. Hello.
Dipshika, you told that you have downloaded the yes. Hello.
Yes, sir.
You
Yes, sir.
downloaded the data
Okay.
user repository, but which data set you have used? It is not mentioned, and how many were in that particular data set?
Sir, I take data from UCA repository. I take data of some patients from just like
How
hospital data is there. So I take data. Yes, sir.
Yes, tell me. How many records were present in that particular data set, and how many attributes are there?
Sir, it's a large data set. I think it's having a record of.
The data set name you have told. Data set name. I used a data set. Yeah. So, what is the name of that particular data set?
So it's a patient related to patient data set. I didn't remember the name.
How many attributes in that particular data set? Okay. Next, have you faced any issues regarding the latency or energy consumption, and how you have faced that particular, how you have tackled that particular problem?
Sir, your voice is not clearly audible.
Latency. Have you faced any issues related to the latency and energy consumption? So, and how you have handled this particular issue?
So actually, this is end-to-end latency means end-to-end delay. So we checked. Yes, sir.
Yes, yes.
So which I check end-to-end delay means that if packets are delivered from source to destination, so it takes less time and all the packets are delivered. So there is no delay in the packet delivery from source to destination.
My question is, if there is any, so there is no any.
Yes, sir.
Hello. You told that there is no any. Miss.
So in my work, I just try to reduce the end-to-end delay.
Yes.
Like if packets are delivered from source to destination, so it takes less time in and delivered in throughput. I just found that more packets are delivered with less loss. And end-to-end delay means from source to destination there is no delay of that packet delivered. That packets are delivered, there is no delay. So we try to reduce that end-to-end delay, that packets are not in its packet or take more time to deliver.
Okay. Have you think about any real world application or scenario where you can apply your this particular system?
Yes, sir. Just like we use this thing in, we can take this thing in the hospital. We can also take hospital data, real time data. We also take, but I take only data from online repository. So when we take real time data and we after applying these things, we can use this thing to the person. Just like if we talk about blood pressure, so we can use these things. Just like normal blood pressure is 120/80. So if blood pressure increases, so it creates if blood pressure rate goes from above 150, so it's range from emergency. So we can use this thing to that. because I take those things, I just find out that if there is any problem, there's an emergency, so we can take this, we can apply this thing, and we can find out the emergency condition.
Okay, thank you. Thank you, Dipshika.
Okay, Dipshika, we have a question.
Have you compared your proposed model with other existing model?
Yes, sir.
Have you compared your proposed approach with the another existing approach?
So I just found those things, but I just compared my algorithms with, just like if we use these things without using this classification, so our results are low. Just like if we don't perform any classification, so our results are like this blue arc that shows. But if we apply these algorithms, our results are good. So I just work on these things.
Okay, okay. Thank you, Dipshika. Please, please close your slide, and we move to our next presentation. Sir, Jagan sir, can we move, sir?
Yes, sir. Yes, sir.
Okay, okay, sir. Thank you, sir. So our next paper ID 110. Paper ID 110 is here. Is anybody here from paper ID 110? Can admit.
He is waiting.
He is telling that there is nothing to say. Okay, 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 okay. That's why. Okay, can we move to paper ID 234? Is anybody here from paper ID 234?
Yes, I'm here. Wait a moment.
Okay, 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 Sant, please share your complete presentation on your screen,
Okay.
and open
Wait
your
a
camera
minute.
and start. We have 10 minutes and 5 minutes for Q&A, okay?
Okay, sir.
Okay, okay, start.
Wait a moment, sir. Sir, give me a second. Sir, is it visible?
Yes, sir. Is it visible? Please full screen your slide and start.
Wait. Okay. Good evening, professors. My name is Sant Kumar Maurya. I'm an assistant professor in Chandigarh University. So this paper title is.
Sant, hello, sir. Please
yes.
make it full slide, full screen of your slide.
Sir, actually, from my side, it is full screen.
Okay,
now,
okay.
Now again, I am. Is it full screen now?
No, no, no. It is not. Can you once do it for us? Okay,
Okay,
okay, no problem, no problem. You continue yours. Okay, okay, no problem. Continue.
Okay, so the paper is back propagation neural network based routing optimization for IoT. Wait. This is a table. So basically, we focused on this paper for error reduction. As we know that in these days, Internet of Things are very rapidly growing. So each IoT things or devices requires some bandwidth or sending some data. So in the network, if there is a error, and that is the issue. So we are trying to reduce the errors. So basically, we focus on some different types of data communication or data transfer like RFID, NFC, wireless sensors, internet, and VNet. So as we go through some recent papers, and so we analyze that to transfer the data, routers are the most important devices for delivering the data. So if you will see, there are many protocols to handle the data and transferring the data. So the back propagation is in neural networks. is also a type of a technology where we try to send the data and again backtrack the data. For example, there are many types of routing technologies like link state, a distance vector, and some others. But in the back propagation, first we'll send the data and again we will backtrack the path. Okay, just in the figure, we are taking some input from one source to some destination, and by using any routing like link state or distance vector or anyone, so we send the data or packets through multiple nodes. So if we will implement back propagation, then it will it will track the path of the data from source to destination and from destination to source, and after that it will analyze that on which path the error is low. So after that it will change the path from source to destination as per the less error detection, or where that error will be very low. Error means the you can say that the dropping of packet or a delay in packet. So in the before it, some authors have done some works, and they give some comparison of some types of routing protocols and some technologies, and I conclude them and compare them, and again we applied the back propagation technology in the routing. Finally, in this paper, I focused on top three types of routing, which was implemented by the authors. First one is the ad hoc on-demand distance vector routing protocol. In this, when we source node want to send some message to some destination node, it broadcasts route request message to its neighbors. And finally, when route replies the message, travels back to the source, the nodes along to the path, the forward route tables, which point to the node from which the rep come. And second one is the dynamic source routing. So in this, the author concludes the route discovery and route maintenance. And third one is optimized link state routing. In the link state routing, we, for example, all the nodes will send their routing table or routes to the neighbors. And after that, after some time, all of they have the entire network routing table, and they will update with each other. And this is the finally BPNN based routing optimized for the IoT.
Hello. Sir, please make it quick. Okay.
Okay.
Make it fast. Okay.
Okay.
Continue.
So in this technology or in this routing, we cover the like fault tolerance, scalability, error, and if we'll talk about the results, we compare with three previous proposals. Like that was the ad hoc, DSR, and OLSR. So if I do it in the network simulator too for the testing, and if we'll take the number of nodes as 50, then the data accuracy to send the destination is 90%, and previously they were giving the 83%, 85%, and 82%. So by using this propagation neural network based routing, we get some better results as previous. Thank you.
Sir, any questions, sir? Hello, sir. Sir, your voice.
Sir, your voice is not audible to me.
Hello.
Yes, sir. Yes, sir. Yes, sir. Your voice is not coming.
Sun, sir. Nice presentation. So,
Sir, your voice is not more clear, sir.
hello. Am I audible, sir?
Yes, sir. Yes, sir. Yes, sir. Of course, sir. Of course, sir. You can ask.
Sir, Sun, sir.
Yes.
Told that this because of this your particular approach throughput will be improved. Okay.
Yes, yes.
Sorry.
Not only
Optimization.
throughput, sir. Actually, we the result is we reduce the error.
Yes.
Yes.
So you have considered only accuracy as a performance matrix. Okay. Is there any
Yes.
another matrix related to this optimization which can be considered?
Actually, I am doing for some another matrix. Right now, I do for that only.
Okay. Second question, sir. Suppose there are any network dynamics or any changes in the IoT network, then how can your approach will adapt to these particular changes?
You mean, sir? This is for IoT network as well, because in these days, IoT devices is uh, sending a lot of data. So for that, this approach is I propose.
Yes, but in IoT also, suppose there are any changes occurs, then is there any features or have you checked that your system, your approach is capable to handle such type of the dynamics? Is there any changes in the IoT
Sir,
network also?
back propagation is itself that if they are, it will analyze every time for the entire nodes. For example, there are 80 nodes in between the source and destination. It will always analyze that what is the best path for us for the less error and maximum performance. And if there will be some changes, then it will be change the path.
Okay, thank you, sir. Thank you, sir.
Okay, sir. Okay, sir. Sir, shall we move, sir?
Yes, sir. Yes.
Okay, okay.
Okay. Thank
Sun,
you.
okay, okay. Thank you. Please shut your slide. Then we will move.
Okay, wait.
Okay. Okay. So the next paper ID we have 110.
Excuse me, sir. 219 is present here, so can we go ahead?
Okay, okay. You can go. 219 is it offside detection for improved decision making and gameplay in football?
Yeah,
Is
yeah.
it? Okay. So okay, you can go on. Please open your camera, start your camera, and start present yourself and screen your share.
Yes.
Share your screen. Sorry.
Is it visible?
Yes.
Yeah.
Just
Is it
share full
visible?
screen.
Yeah, yes.
Okay, let's start.
Okay. Good afternoon, all. Good afternoon, sir.
Good
Hope you
evening.
all doing well today. Yes, my name is Devyani Dhokal, and I'm honored to present before you a research on topic offside detection in football. And I have with me another author, Mr. Asharullah, today. So before we dig deep into the topic, I would like to introduce our institution as well. This research is conducted under Vishwakarma Institute of Technology, Pune, and under the guidance of Professor Dr. Jyoti Madke. Okay.
Okay, first of all, Ashar and
Yeah.
Devyani, you have 10 minutes and 5 minutes for Q&A. Okay.
Sure.
Okay. Start.
So in soccer, offside judgments are critical, and we have used computer vision to automate this procedure in our research. Our unique approach combines HOG for human detection with color histograms for player team classification. We have developed a custom algorithm for real-time offside detection, tested rigorously on a publicly available dataset as well. And our method achieves exceptional accuracy, and uh, our research has the potential to enhance the fairness of this soccer game further. Okay, next slide. So we have seen scenarios where, despite of the use of VARs, there is still inappropriate and inconsistent decision making happening in football. So our mission here is to present a computational algorithm that is designed to determine possible offside players in soccer games and to establish a benchmark for future research in this area to increase the accuracy in offside detection in soccer. Next. Okay.
Okay. So before we dive into what our methodology is, let's understand what is offside rule. So as you can see in the image, let me take a. As you can see in the image, we can clearly see two teams. One is the attacking team, that is yellow team, and one is the defending team, that is pink team. So at any point of the game, what offside rule states is, if a pass is placed to attacking player behind the defending teams, all the defender, at this point of time, this player, he is in an offside position. And any further game that he does, or that if he scores a goal, it will not be counted. Because as you can clearly see, he's ahead of the line of all the defenders. So he is in an unfair position. So game should have to be stopped here. And that's what we are trying to do. We are trying to tell you that if a player is in an offside position or not. So here is the methodology that we are trying to use. So first, we collected our data from publicly available data set. Then we applied some pre-processing on the data. And after pre-processing, we extracted human figures from the data. And then we augmented the extracted human figures. Then we trained our model on those extracted figures. Then we classified the teams. And then we applied a custom algorithm for detecting if he's in offside position or not. So about the dataset, it is being taken from Kaggle and it belongs to a German football league named Bundesliga. And it had 200 videos, out of which we chose to use the data specific to these two teams because the contrast in the jersey colors. And this is the first step, that is extracting each frame and cropping the excess areas. Like you see here, we have cropped the what we can say audience stand, and we have cropped the unwanted players because referees and sideline players are not involved in the offside detection. We just need the field. We also even don't need the referee that is on field. We have also inducted that into our system. Moving ahead.
Okay, after this pre-processing step, we had pre-processed images from the video. And what we had to do now, our goal was to extract human beings from that. And for that, we used HOG. So HOG stands for histogram of oriented gradients, and it's a feature descriptor that is used in object detection. This technique counts occurrences of gradient orientation in the localized portion of an image. And the resulting histogram is then used as a feature vector that represents the image region. Finally, the windows were classified using an SVM classifier trained on a large dataset of images. So after this process, we had images. We manually classified them into different teams. As you can see the screenshot there, we had 3 teams. For white player, for others counted referees and other people there. And the lemon team was the second team. Next slide. Okay, so now we had data for teams players as well. So what we had to do now is to tackle the problem of underfitting, and for that we use the famous method augmentation. We use different augmentation techniques such as rotation, zooming, vertical flip, horizontal flip, and many more as mentioned in the second point. And now we had, after this augmentation, we had a data set of almost 4,000 images, which was enough for training our classifiers. Next slide.
Okay. So now, as we can see here, that we have three main classes that we have here. The team A, that we see the white team, team B, the green team, and the other class. Here, what images were stored, like I said before, the referees, the goalkeepers, that are not part of the offside decision making. So what the first thought comes to mind for classifying these is based on their color. So what we did is we chose color histogram as their feature, and we plotted this BGR values into 255 bins. Like for blue color, there are 255 bins. For red color, there are 255 bins. And for green color, there are 255 bins. So here is the feature that we got. So as Devani mentioned, there were 3,880 images. And for each image, we have 765 columns. And what these columns represent is, like for blue color, we have 255 bins into 3. That is 765 BGR. So we used classifying classifiers which
Utkarsh, you are from paper ID 110, na? Utkarsh, am I audible, Utkarsh? Okay. You can continue, sir. Ashar and Divan, you can continue. I'll make it fast, okay? Make it fast and come please close to the conclusion, okay?
Yeah, we are on that.
Okay.
Okay, so these are the accuracies that we got from different classifiers. And now let me take you through the most important part, that is result and our custom algorithm. So how our custom algorithm works is, first, as you can see in the topmost image, that we are classifying into 3 classes. First, you can see the referee in a black box because he is not relevant to the offside detection, the green team and the white team. In the second image, the second step of the algorithm comes where we classify and distinguish the last players on either side of the field. And what we came up with the logic is that if the last player at each side of the team is same, that means the defender of the same team and the attacker of the same team is present at both ends of the field, then it can tell you the game is in a possible offside condition. But here it needs human intervention, that if ball is passed to this last player, only then the game has to be stopped. So here there is a catch in our project. So that's our algorithm. So that is pretty much it. Devani, if you want to continue.
Yeah. Okay. So there are still scope of improvement, and we are working on that. And after this all, we can conclude that we have put forward an algorithm that works successfully to detect the possible offside players in soccer games. Yes, that's it. Thanks. We're done with our presentation and we're open for questions. Thank you.
Okay, sir. Any questions, sir? Jagan, sir? Hello, sir. Jagan, sir? Sir, your voice again. Hello, Jagan, sir. Your voice again not reach from us. Yes, sir. Now it's coming.
Hello.
Hello. Hello.
Am I audible, sir?
Yes, sir. It is, sir. Sir, you can go on.
Devani and Akshar, a nice presentation you have given, and topic is also nice, offside detection for the football. So is there any specific challenges you have handled and which are associated with this particular football? And this whatever challenges are there, all challenges can be resolved by using your algorithm?
I would like to answer this.
Yes.
Yes. So when we went through our literature survey, a few papers, we found this research gap there. There was a lack of real-time processing, which we tried to tackle by doing this all process on a video, we can use cameras there, no, on field and apply the same technique there. And second was the feature extraction, that we segmented teams. That was a bit used a bit complicated there. We use color segmentation, which is easier, and again we used computer vision based approach for this.
You have downloaded the data from which website?
Kaggle.
Kaggle. Kaggle. Okay. The algorithm which you have given, that is your algorithm, or it is already existing and
No, we designed that algorithm, and it does classification at multiple places while going through the final result, while giving the final result.
okay. From you have mentioned 3 algorithms. So which algorithm gives a good result? SVM. I think you have given only 3 algorithms there in comparison.
Yeah, those classifiers that we took, if you can see the screen. This we took for classifying the players into their teams, and the third class, that is other class. And the algorithm that predicted the offside decision was created by us. The algorithm, as you see here, the pseudocode of it.
Sir, we cannot really hear you.
Is he stuck or?
Sir, Jagan sir? Hello? Hello? Sir, your voice and your... Hello? Jagan sir?
If there are any internal questions.
Okay. Let me check it. Sir, any questions? No, sir. No internal question. No question from any internal side. Just wait for the again. I think he will join. Okay, give us a second. तब तक के paper ID, is anyone present from paper ID 110?
Yes, sir, I'm there.
Okay, paper ID 110 na, you are with na, so is Manik Rathra?
Yes, sir.
Okay. Please wait and till complete then. Okay.
Sure, sir.
Okay.
Hello.
Yes, sir. Manik sir, Jagan sir.
Yes, that's it from my side. I have asked a question regarding the challenges, and next is the algorithm. So that this algorithm, yes, our offset algorithm you have designed. Okay.
Yes.
Okay. Thank you.
Thank you.
Okay,
Thank you,
thank you,
everyone.
sir. Thanks for your time.
Okay. Asher and Javani, please close your slide, and we will move on for the another. Jagan sir, can we move to the another presentation, sir?
Yes, sir.
Okay. The paper ID 110.
Yes, sir.
Okay. Please open your camera and start your presentation. You have 10
Yes,
minutes
sir.
for your presentation and 5 minutes for Q&A. Okay, am I clear?
Okay, sir.
Okay,
sir.
Okay. Start your presentation.
Yes, sir. So is it visible?
Yes, is it visible?
Okay. Good evening, to the session chair and all my fellow researchers. I'm here to present on the topic utilizing correlation analysis for validation of image data sets in lower spine diagnosis. In this paper, we collected data from different labs in Punjab, and for the analysis of lower back pains that can be caused due to a variety of reasons. We did the pre-processing using correlation analysis, slicing, and contrast segmentation to validate the whole data set. Out of the 5,000 samples that we retrieved, only 3,032 samples were having a positive correlation, while the rest had a negative correlation. To go further, I would like to uh, introduce the topic of lower back pains. The lower back comprises of the lumbar spine, which is formed of vertebral bones, intervertebral discs, nerves, muscles, ligaments, and blood vessels. The spinal cord ends at the top of the lumbar spine, and the remaining nerve roots, called the cauda equina, descend down the remainder of the spinal canal. The lumbar spine injury causes severe pain, and its detection at an early stage is critical. These are the several parts of the lumbar spine that we are going through for this project. Uh, the lumbar spine from L5 to L4 detects helps in the movement of the legs, while the rest of the from L1 to L3 helps in uh, giving support to the whole back. So, going to the parts of the spine, the vertebrae uh, is made up of small bones which are stacked on top of one another and create the natural curves of your back. The second part is the muscles and ligaments. These provide support and stability for your spine and upper body. Strong ligaments connect your vertebrae and help keep the spinal column in position. The third part is the intervertebral disc. Intervertebral discs sit in between the vertebrae. They are flat and round and about a half-inch thick. Intervertebral discs are made up of two components, nucleus pulposus and annulus fibrosus. So there are a number of problems related to the lumbar spine. These are the most common occurring disease is, sorry, sir. The most common occurring disease is known as the lumbar disc disorder, which is commonly caused when the structure of the disc gets abnormal. The age factor, wear and tear of the disc, injury, etc., can cause this disease. A disc may herniate gradually as a part of general wear and tear or suddenly due to injury or heavy lifting. The forward slippage of a vertebra over the one below it is called uh, spondylolisthesis, and facet joint osteoarthritis is the age-related wear and tear that causes the cartilage covering the facets to become worn and frayed. So in the project, we went through the following methodology. Firstly, we collected 5,000 samples from different labs and hospitals in the region of Punjab, India, and we pre-processed the data using histogram analysis, median filter, validation of the data set, normalization, histogram equalization. So I'll walk through all of these steps individually. Firstly, histogram is a graphical representation of the intensity distribution of an image. It can be interpreted as a data structure that shows the frequencies of all the pixel intensity of the image. So here we present the grayscale image histogram and the RGB image histogram. Next, we went for the median filter. Median filter considers each pixel in the image in turn and looks at it nearly to decide whether or not it is representative of its surroundings. Instead of simply replacing the pixels, the mean of the neighboring pixel values, it replaces it with the median of those values. Next, we went for the validation, where the images we obtained from the pre-processing was checked against the initial image, and a threshold value of 30% was set for the validation. If the differences between the first and the second images more than 30%, the images were discarded. Next, we went on to the normalization process, where we divided each of the pixels, which ranges from the value of 0 to 255. We divided it by 255 to convert the range into 0 and 1. And then we moved on to histogram equalization, In histogram equalization, and it is an image processing technique that adjusts the contrast of an image using a histogram. To enhance the image's contrast, it spreads out the most frequent pixel intensity and stretches out the intensity range of the image. By accomplishing this histogram equalization, uh, it uh, converts the image areas with lower contrast to gain a higher contrast. This is the graphs we obtained from the histogram equalization.
Manik,
The,
please
yes,
make
sir.
it fast. Make it fast. Make it fast.
Okay, sir.
Mhm.
Then we went on to slicing, where we divided the image into critical and non-critical areas, segments, and the non-critical segments were eliminated and the critical segments were retained. And then we went on to contrast stretching, which is again a method to increase the contrast of each image and each pixel of the image. And then we went on to feature extraction using principal component analysis. We calculated the covariance matrix and computed the eigenvectors and eigenvalues and retained the values having the highest variance values. And then we went on to correlation analysis, where we found that 3032 images had positive correlation and 1968 images had negative correlation, where the maximum correlation was obtained as 0.99 and the minimum correlation was found as minus 0.98. On the whole analysis, we had the following results. The study's primary emphasis was on validating image datasets for use in lower spine diagnosis using correlation analysis. The study's MRI image collection was generated from different labs in Pathankot, which is a region in Punjab. The purpose of this research was to answer the pressing need for information, uh, gaining diagnosis of disorders affecting the lumbar spine. Correlation analysis was used to verify the data sets and validate the whole image. And several pre-processing methods were used, uh, after which we found that 3032 images had a positive correlation, which suggested the spine detection had been compromised. These are the images we obtained. The left side image is the image before applying histogram equalization. And after histogram equalization, we find that the contrast of the images have been increased. The second is for the before and after slicing. Before slicing, we can see that the images have several non-trivial segments, whereas the images on the right have only the trivial segments. And the next part is the contrast enhancement. And we can see that the left side images have a lower contrast to the right side images. To conclude, I would say that using an MRI image dataset generated from several laboratories in Punjab, we concluded by discussing the use of correlation analysis in validating image datasets of lower spine diagnosis. Data collection, validation, and pre-processing approaches highlighted as crucial to the study's success in providing a trustworthy diagnosis. Several research gaps were discovered despite the fact that several parts of collecting validation and preparation were addressed. There was a requirement of external validation and assessment of clinical effect. However, this was not applied and was also a lack of investigation into alternate data gathering methods. Thank you.
Okay, thank you, Mayor Manik. Sir Jagal sir, any questions, sir? Sir, your voice, sir.
Sir, you're not audible. Sir, you're still not audible.
Now?
Yes, sir, now you're audible.
Hello.
Hello.
Yes, sir.
Yes, sir,
Yes, sir.
you're
Sir,
audible.
you're audible now.
So
Sir,
again, your voice is.
sir, again, your voice is troubling, sir. Sir, Jagan, sir. Sir, can you, sir, rejoin again, sir? Okay. Manik, sir, please wait.
Yes, sir.
Just wait. He will rejoin and ask the question. Okay.
Sure, sir.
Okay.
Yes, sir. Hello.
Hello.
Yes, sir. Now.
Sir.
Yes, sir. Now you're
Yes, sir.
audible.
Yes, sir. You're audible, sir. Okay.
Manik, you told that you have collected 5,000 records
Yes,
from
sir.
hospital. So you got this data from these hospitals. There are any ethical issues regarding this?
So we signed the required paperwork for collecting the data.
Then any correlation metrics used in your research? Because you are not shown any matrices. How you compare that your system is a good? So any matrices you have considered here?
So we use the normal correlation analysis using chi-square test, and we check the data against the different features which we obtained using feature extraction.
Any unexpected correlation occurred during your this implementation?
Yes, so there were some samples where we obtained no correlation, which means it was between 0.2 and minus 0.2. And to remove that, we further used this contrast stretching.
Okay. Any features for your this particular system? Any features?
Excuse, sir, could you repeat?
Feature scope, have you planned any feature directions?
So I could not understand your question.
Any future direction you have decided to extend your this particular system?
Your future scope.
Yes, sir. We are right now we are going for the classification of different uh, uh, problems associated with the lower spine. Right now, we just went for the pre-processing methods and validating the data set. Now, further, we'll move on to the machine learning and predictive analysis.
Okay. Thank you.
Thank you, sir.
Okay, sir. Okay. Thank you, Manik. Thank you, Jagannath, sir. Most heartfelt. Thank you for your most precious time for us. Here's some talk with you, my sir.
Thank you, Jagannath, sir, for joining
Thank you,
us.
sir. Thank you, sir. Thank you.
Okay, sir.
Thank you, sir. Sir, give us some. Sir, your time is most precious to us, sir. Thank you, sir. Sir, can we end it now?
Yes, sir.
Okay. Thank you, sir. Thank you most, sir.
Thank you. Thank you. Thank you.